All right, Math 30-1, Chapter 4, Trigonometry and the Unit Circle. This is part of Unit 2 on Trigonometry, and we're on 4.1, Angles and Angle Measure. First of all, let's look at the difference between radians and degrees. As you know, it's 360 degrees to go around a circle. 180 degrees to go halfway around a circle. We're going to look at measures of angles in radians instead of degrees. Now, if you look at this, we have an angle, BOA. The radius of these two arms and the arc formed by arc BA are all going to be equal. They're all going to be equal to R. In this way, in every circle, that angle is going to be the central angle, and it's going to have a measure of 1 radian. So this radius of this circle is said to be R. The length of the arc subtended by the central angle BOA is also going to be R, and the central angle, again, is 1 radian. Now, if we look at the circle in degrees, 0 is the starting point. Halfway around the circle is 180 degrees, and we hit 0 again, we're at 360. Quarter of the way around is 90 degrees, 3/4 of the way is 270 degrees. Now we can also measure this in radians. Halfway around the circle is going to be pi radians. All the way around the circle would be 2 pi radians. 90 degrees is pi over 2, and 270 degrees is said to be 3 pi over 2. Now, one complete rotation, 360 degrees, is said to be 2 pi radians. 1/2 rotation, as I said, is 180 degrees, or pi radians. Quarter rotation, 90 degrees, is pi over 2 radians. 3/4 of a rotation, 270 degrees, is 3 pi over 2 radians. 1/8 of a rotation, 45 degrees, would be pi over 4 radians. Many mathematicians omit the units for radian measures. For example, 2 pi over 3 radians may be written as 2 pi over 3. Angle measures without units are considered to be in radians. And to this we can add pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. We're going to get into more of those a little bit later. In an example 1, let's look at this angle. It says to draw each angle in standard position. The first one's 30 degrees. Change each degree measure to radian measure, and each radian measure to degree measure, and give answers in both exact and approximate measures if necessary to the nearest hundredth of a unit. First of all, we're going to use the ratio 180 to pi, because 180 degrees is pi radians. So 180 degrees would be 30 over x. By cross multiplying, we can solve for x, so we can say 30 times pi divided by 180 would equal x, and reducing, dividing 30 into the top and 30 into the bottom, x will equal pi over 6. Pi over 6 is exact. Pi divided by 6 is equal to 0.52. That would be our approximate measure to the nearest hundredth. Let's move on to B. In B, we've got negative 120 degrees. So you'll notice that negative 120 is going to go down there. 180 over pi is negative 120 over x. Again, we're going to cross multiply and divide. That means that we're going to get negative 120 times pi over 180, and that's going to be negative 2 pi over 3 if we divide both the top and the bottom by 60. That, of course, is our exact measure, and our approximate measure is about negative 2.09. Here we go with C and D. First of all, with C, there's 5 pi over 4. 5 pi over 4, remember pi is 180 degrees, so 5 times 180 over 4 is going to give me a measure of 225 degrees. In the last one, we've got 2.57. That, of course, is going to be in radians because it doesn't say degrees. So 180 over pi is x over 2.57. And cross multiplying and dividing by pi, you're going to get 462.6 degrees divided by pi for an exact answer, or 147.25 degrees as an approximate answer. Let's look at what we call coterminal angles. When you sketch an angle of 60 degrees and an angle of 420 degrees in standard position, the terminal arms are going to coincide. These are called coterminal angles, because if you go around once, twice, 3 times, and you're always landing on the same spot, they're called coterminal. In A, it says determine one positive and one negative angle measure that's coterminal with each angle. If we started with 40 degrees, I could add 360 degrees, or one rotation, to get a coterminal angle of 400 degrees. Or I could start with 40 degrees and subtract 360 degrees and end up with negative 320 degrees. That is also coterminal. Let's look at B, negative 430 degrees. Well, if we started with negative 430 degrees and added 360 degrees, I'd be at negative 70 degrees. Now, if you want a positive angle, I can start with negative 70 degrees and add another 360, and that will take me to positive 290 degrees. In C, 8 pi over 3. Well, got to remember that when I take away 2 pi from 8 pi over 3, 2 pi is the same as 6 pi over 3. Got to learn your fractions. 8 pi over 3 minus 6 pi over 3 would give me 2 pi over 3. Now I can start with 8 pi over 3, or I can start with 2 pi over 3, subtract 6 pi over 3, and I'd have negative 4 pi over 3. That way I'll have one positive and one negative coterminal angle to 8 pi over 3. Coterminal angles in general form. By adding and subtracting multiples of one full rotation, you can write an infinite number of angles that are coterminal with any given angle. So instead of writing every single angle, what we do is we come up with a general formula, and that is that the coterminal angles to something like 180 degrees would be written as 180 degrees plus or minus 360 times n, where n is any natural number. And for B, 3 pi over 2, if we used radians, we'd say 3 pi over 2 plus or minus 2 pi n, with n being any natural number. So let's express the angles coterminal with 110 degrees in general form, and identify the angles coterminal with 110 degrees that satisfy the domain of negative 720 degrees all the way up to positive 720 degrees. And then in B, we want to express the angles coterminal with 8 pi over 3 in general form, this time from negative 4 pi all the way up to 4 pi. So here's A. 110 degrees plus 360 times n. Now we can go and say 110 minus 360 is negative 250. I can subtract another 360, or 720, and I get negative 610 degrees. Those will be my two negatives. Now again, if I started with 110 and I added 360, I'm going to get 470 degrees. And if I went 110 plus 720 degrees, I'd end up with 830 degrees. But notice that 830 degrees is beyond 720 degrees, so we're going to have to cross that one out and say that 830 degrees is outside of our domain. Those are our three answers for this question. B. 8 pi over 3. If I subtracted 6 pi over 3, I would get 2 pi over 3. 2 pi over 3 minus another 6 pi over 3 would give me negative 4 pi over 3. Now, 4 pi over 3 minus another 6 pi over 3 would give me negative 10 pi over 3. What's my domain in pi over 3? Well, let's convert negative 4 pi to negative 12 pi over 3 and positive 4 pi to positive 12 pi over 3. Now you can see that I'm as low as I can go. Negative pi over 3, because the next lowest one would be negative 16 pi over 3, and that would be below negative 12 pi over 3. So let's go up now from 8 pi over 3. And that would be 14 pi over 3, which again is beyond our domain. So those are our only four answers that are available. 8 pi over 3 plus or minus 2 pi n, where n is any natural number, is going to be how I'd write my answer in general form. Arc length of a circle. All arcs that subtend to a right angle have the same central angle, but they have different arc lengths depending upon the radius of the circle. The arc length is proportional to the radius, and this is true for any central angle. Now, what you need to know in this is that the bottom line there tells us that A is equal to x times r. That's the equation we're going to use in the next page. Now, if we consider the circle with radius 1 and the sector with a central angle of the angle, the ratio of the arc length to the circumference is equal to the ratio of the central angle to one full rotation. This means that x is going to equal our angle. If we substitute our angle into 1, A is equal to our angle times r. This formula that's highlighted, A equals our angle times r, works for any circle provided that our angle is measured in radians and both A and r are measured in the same units. Let's look at an example. We have, first of all, determine the arc length in a circle. Well, to figure out the length of that arc, we're going to say 180 over pi. It needs to be in radians first. Is going to equal 130 over x, cross multiply, and we're going to get 13 pi over 18 radians. So now using our equation, A is equal to our angle times r. A is going to equal 13 pi over 18 times 6.7, and that's going to give me 87.1 pi over 18, or approximately 15.2 millimeters. Your assignment day 1 is to do page 175, numbers 1 to 8, and your assignment on day 2 is to do page 176, numbers 9 to 19, and 21.